Yeah.
So
An asymptote is not a part of the graph, so the function will never lie on the asymptote, but it can approach, and it will. That's the idea of an asymptote, is that it's going to approach. It'll approach it. Okay. So as a quick review, a function has a vertical asymptote at any place where the function has a 0 in the denominator. Okay? So anything in the denominator of a function that will make the function 0 will give you a vertical asymptote. A horizontal asymptote, you can only have one. So you're either going to have 0 or 1. Okay? And whether you have an asymptote, you're going to have to determine by comparing the degrees of the numerator and the denominator. So if the numerator is a lower degree than the denominator, then the graph does have a horizontal asymptote, and that asymptote is the x-axis. So anytime the numerator is a lower degree than the denominator, you'll have a horizontal asymptote at the x-axis. If the degrees are the same with the denominator and the numerator, then you will also have a horizontal asymptote. And that asymptote is going to be the ratio of the leading coefficient of the numerator over the leading coefficient of the denominator. And that at that line, you'll have a horizontal asymptote. If the numerator is larger degree than the denominator, so if you have a higher degree in the numerator, then you won't have any horizontal asymptote at all. So this is one of those things that you just sort of have to memorize, and when you use them, hopefully, as you use them, you'll get a handle for that. But you figure with any of your other courses, history or biology or literature, you memorize some stuff. So I think for math, sometimes you get the idea that we don't have to memorize anything, we just learn some formulas. But
I gave up that idea a long time ago.
if you actually memorize those 3 rules, this whole section is really pretty easy. It's all using all of the things that you learned in the past. So you're not learning anything new. All you're doing is applying those to these 2 sets of rules, one for a horizontal, one for a vertical asymptote. Okay? So what we'll do is we will do a few of those. Okay. All right. Determine where the asymptotes are located in sketch. All right. So my starboard here doesn't let me do that, so I put the little slash to show it. So I'll rewrite that just so you can see exactly what we're talking about. So we're talking about 5x over x minus 1. Okay? So this graph, f of x equals x minus 1. The first thing I have to do is take out any common factors, and there are none. Okay? You can't reduce it any further, in other words. That's as simple as you can get. You have a function in the numerator. That function is or 5x, and then in the denominator x minus 1. So you're going to have, first we look for the vertical asymptotes. So, and that's basically going to be at any place where the denominator would be 0. So what x values would give us a 0?
What?
In our function that I gave you, is 0?
Oh, no. Just kidding. Is it just the bottom one?
I'm just kidding.
Yeah.
1.
At 1. Okay. So if x is 1, then this whole thing is undefined. So x can never be 1. So this whole line here, and I'll just make sure that I do have a smart, make sure it's the IntelliPen. And it is. Okay. So this whole line here,
Is this going to make the line straight for you?
it will.
Oh.
So there's a vertical asymptote there at, what's that?
That can't ever be.
Right, so your function will never touch the line x equals 1.
Okay.
So that's all that is. And now there could be, that's the only one there is, but there could be an infinite number of vertical asymptotes. It's any place that x will be 0. In this particular function, you only have 1, because the only value of x that will make the denominator 0 is 1. But again, as you go on, you can find more than one of these. So for this one, it's the simplest one, and there's just one, and it's at the point x equals 1. So that's easy enough, right? All right. To find a horizontal asymptote, we compare the degrees of the numerator and the denominator. So what degrees do we have?
1 and 1.
So the denominator and the numerator are both first degree polynomials, so they equal. So if our polynomials have equal degrees, Do I have a horizontal asymptote or not?
Yes.
I do have one. And where am I going to have it at?
I don't know that.
It's at the ratio of the leading coefficient. So what's the leading coefficient up here?
5.
What's the leading coefficient down there?
1.
1.
Yeah.
So it's it's the line. Oh, I'm still.
I like it though.
Yes. It's the line y equals 5. That's all. 5 over 1 is 5. Okay, so if I do that, y equals 5. So I have a horizontal. So I have a horizontal asymptote at the line y equals 5. So I have two asymptotes, so my graphs will never touch that. And so to sketch that, well, that's not too bad. So we know it's going to be moving towards our asymptote, so we just need to put in some test points, and if you use some simple ones, it'll help us. If you put 0 in, 0 is almost always a good one, because that cancels a lot of things out. So if x is 0, what point do I have?
0. 0, 0. Besides.
So, I'm sorry?
0.
If I put in x at 0, what's my y value?
0.
Right, 0, 0. So,
You gave me a look
Yep.
like I was wrong. Let's do that, please.
so that's my point, 0, 0.
Tell that to me.
Huh?
Nothing.
And then, so that's one point. So let's put in another one. What if
2.
we know it can't be 1, so good. 2 would be a good one. What would 2 give us?
10.
10. So 2, 10.
But
Up
they
here.
cross it.
What?
They, never mind.
We're just saying that they're not going to touch. What if, what about 3?
7 and a half? No, wait,
Well,
no.
it's 15 over 2. Right?
7 and a half.
Oh.
Right.
Good one.
Okay.
Why did
Oh, wait, are you going to have 2 graphs?
Well, it's only one graph. But it's not going
No,
to touch
I
the
mean, like
asymptotes.
two-
It's going to be parts, yeah.
Okay.
Why?
So the one is going to go like this, and the other
What
one's
is it going to
go
be
like this.
if I have x's 6?
Why?
Huh? What's y going to be if x is 6?
5.
6.
No. Wait, yeah. No.
If it's 6, we have 30 over 5, which is 6. So 6, 6.
I did it right.
I did it.
Is that enough for you to see what's happening up there?
Sorta, yeah.
So then what's happening with the 0?
Well, let's see. So we know we got something that looks like this, right? It's going to approach those asymptotes, but it's not going to touch them. So that part, we know what that
Oh,
is.
that's
Oh, we're
cool.
going to have to make a negative now.
So what if it's, well,
2.5.
6 came out easy. What if it's
Positive-
negative 6?
Positive. Oh.
Negative 6.
Negative.
No, that's ugly. Let's not do
No,
that,
no, no, I'm
please.
just kidding.
All right, go ahead. I don't care. Pick a number.
I like 2.
You like
do
2?
negative 1, and it's 2.5.
If I do negative 1, it's negative 5 over negative 2. All right, so 1 and 2.5.
Yeah, positive 2.
Okay.
So you gotta use the fat one.
Well, it's easier for you to see it if I do it like that.
That's 3.
Is that enough for you to see what's going on, or do you need to plot another one?
I need to find another.
All right, so do one at negative 4.
Oh. Ooh.
That would be negative
4.
20 over negative 5.
4. Negative
4.
Positive 4.
Is that
Okay,
enough for you
I
to
see
see?
what's going on.
Now you can see
I
what's
get,
going on.
I get
I
what's
totally
going
got this when it went like.
This makes sense.
Okay, so our graph will look something like that. And that's all they're really asking. All right.
Oh, okay.
No, but then they're gonna ask like stupid
That's
things on
good
our
to
homework.
know.
What's that?
They're gonna ask us like stupid things on our homework. They always do.
Okay,
Let's find out.
let's see here. 3 over the absolute value of x minus 1. Okay. Vertical asymptotes.
It'll be 27.
What will do I have any vertical asymptotes?
Yes.
1. And negative 1.
What's that?
It's just one, correct?
It's just one, right?
Yes.
Okay.
So just stay with your gut, Kelly. Stay with your gut.
But then, my gut changed and it was like, oh, it's negative
All right.
2. And
Is
then
there-
I'm just kidding, it's not.
Well, if x is negative 1, what's your value?
Negative 2, or positive 2, because it's absolute value.
Right.
Yeah, I figured that out, don't worry.
Okay. So,
Took me a minute, but I figured it out.
okay.
We got this, Sister Savior.
All right. Do I have any horizontal asymptotes?
No.
3.
I have 3.
No, I mean, no.
Most you're gonna have is 1. It's either 0 or 1. So you're comparing your
Negative.
you're comparing your degrees, right?
Yeah, so I was right the first time, it's 3.
0 over 1, 0.
You have 0 over 1. Well, that's your degrees. 0
Oh,
degree over
oh.
first degree, right? Right?
Yes.
Okay. So what does your rule tell you?
Yeah, okay, I got it. now.
0, 0 or 1. It's
I didn't realize there wasn't an X
It's-
there.
so what's my horizontal asymptote going to be?
0.
The x-axis, right?
Oh.
Oh, so there always is going to be 1.
There's not always going to be 1
Why?
because we had a rule that said that if this
Oh,
one
the
is smaller,
numerator's
then
bigger.
right. So you're just comparing.
Oh, that
So-
makes sense. You just sound like an old man. I'll never make that sound again.
So we know that the x-axis will be 1 as well. Well, so now you can plot in some points.
Yeah, we can. Let's do it. Let's plot some points, Mr. Savior.
We can plot as many as you need to see what's going on here.
I want to do 2. Can we plot what 2 would be? Actually, no, I lied. Let's do 4. That'd be a nice one.
4. So 4 minus 1 is 3. 3 over 3 is 1. So 4, 1.
Yeah.
Okay. Can you do 0? 0 is 3 over negative 1. Be what, negative 3?
One more.
What else?
2. I like 2. 2, 3.
2.
That's a point. 2, 3.
So 2 and then 2, 3. Okay, yeah, there you go.
Oh, I think I see where it's going with this.
You probably need at least one more on the bottom, right?
Oh, yeah.
On the top, you can kind of see what's happening.
Negative 3.
Negative 2.
Negative 2. Yeah.
Negative what?
Negative 2.
Negative 2 is negative 1,
I'll leave that.
right?
So,
Okay.
crush
Awesome.
it.
Then we get
So-
the homework.
Oh yeah, it's gonna be totally different when we get there.
Yeah, always is.
And this shouldn't be dotted. I'm just not going to redo my thing. But those are solid lines because those are all on the graph. Right?
Yeah.
Okay.
It's alright, it's green, so that makes sense.
All right.
We should do blue
All right. Let's see.
next. Or yellow. Yellow might not show up. Just
Yeah.
kidding.
So what do I have here? I got 4x over x squared minus 1.
I don't want to do this. Oh, you can simplify it.
Do I have, first, do I have any vertical asymptotes?
Yes. Wait. No. Yeah.
One and there.
Yes, 1. Negative 1. Negative 1.
One. So you're saying I have 2.
Yes, she
Correct.
is. She's got this.
Ben said you can simplify.
Oh, yeah, because.
If you simplify it, then it's x
So it,
plus 1 times x.
so I got 2 vertical asymptotes, and they're at the line x equals 1 and x equals negative 1. So I'll agree with you on that. So what else? Do we have any horizontal asymptotes?
What?
Do I have any horizontal asymptotes?
Yes.
4. Yes, there is one asymptote and it's 4.
No, it's 1.
What's our degrees?
What?
What are our degrees? Because that's what we always do compare, right?
Oh, oh, sorry.
1
I
and 2,
always thought
right?
it was
You just love that leading coefficient.
Yeah, that's what I thought it was. Jeez.
So
Where does the leading coefficient come in again?
if you have equal degrees,
Oh.
the leading coefficients, the ratio of the leading coefficients will give you your line.
Okay.
So what does this one tell us?
It's 1/2.
Right, so is there a horizontal asymptote?
Yes.
Where's it at?
1/2. Y equals 1/2. No. What?
You're just
Why?
You're just throwing into one of your three rules. Which one do you have? Which situation do you have?
What?
You're comparing the degrees of your denominator and your numerator. Your
Yeah.
numerator has a degree of 1, and your denominator has a degree of 2, right?
Yeah.
Isn't one
So,
considered-
which one is that? This is n, and this is m, right? So which of those three situations do you have?
C.
N is less than it?
So there's no horizontal.
What?
No.
You lied to me.
What? This is n here. N is less than m.
What?
N is not greater
Oh.
than m. N is less than m, right?
Read those.
So
Oh,
what do
it's 0.
so what do I have? I have a horizontal asymptote at the x-axis, right?
I'm stupid.
Why are we in this class?
Yeah.
It's okay. Look, so we just have, so this here is a horizontal
I feel like
asymptote.
it did.
Wait,
Okay.
so it can only...
So now it's just
No.
the same thing. You just got a little bit of extra work with plotting because now you have
Just tell
some
me.
extra regions, right?
No.
So wait, it cannot be in between -1 and 1.
I didn't say that. I just said I can't touch those lines. You can have something here. You can have anything,
Seriously?
any of those 6. You
So
don't
you
necessarily
have-
have to,
Oh.
but you could have something in all 6 of those
Okay.
quadrants.
Yeah.
Quadrants is a bad word. I shouldn't use that because that'll confuse you when we do quadrants.
Dude,
But you have 6 different sections of your graph broken up by your 3 asymptotes, and you could have points anywhere in between any of those. The only thing you can't have a point on is where the dotted line is, where you have asymptotes. So let's plot some points. So you got to test them and figure out what you have.
Two something like...
-4. Is it -4 or 0, -4?
0 what?
-4.
0.
If you put 0 in for x, then it's -4. Yeah.
How would you get -4?
Oh.
4 times 0 is 0.
I'm done with this. I'm done with that.
Right? You just
Can't
plug in
do
a 0
this.
in. So if you
That's-
plugged in a 0, what do you have? You have a 0 here over
Negative.
0 minus
Yeah, I
1.
get it.
So it'd just be,
But we can't have that point.
you can't have point 0, -1. Did I?
I don't understand.
Because then it's 0, 0, you can't have it.
Correct.
But I don't understand.
Right, you can't have that point. Because you have an asymptote there.
-1 is 0.
Right here, there's a hole there. So you don't have a point there. So 0 is not a good point.
0's not a good
Okay.
point.
Well, that's not on your
8
graph.
over 3. 2, 8 over...
What?
2, 8 divided
So you
by
want 2. So if I have 2, it's 8 over
3. Yeah.
which is what, 2 1/3? So
I don't
2,
want
2, somewhere like that. Okay.
Sure.
What else?
3 is 12 over 8, which is 6 over 4, which is 3 halves. 6 3 halves.
1 1/2, right?
1 1/2, yeah.
So it'd be
I don't know.
3 1 1/2, 3. And that's enough to probably tell what you got going on there,
I was
right?
going to do, okay, can we do -4?
So we know
So
this
that
is
it's-
looking like this, right?
Why?
Okay.
I'm too stupid.
Now what?
-4, so you have -16 15ths.
-4, and what's your
-16 15ths.
-16
that's
15? So that's almost
And it could be
-1,
positive.
Yeah.
something like that. Okay, you need one more down there to see which way that's going. But -2, -8 over 3, so -2 1/3. And that's enough to see what's going on there. It's not actually going to touch that. It's
No,
gonna go like
it
that.
won't.
And so we know what's going on this section. Now, what's going on in the middle here? So we know that this point's not on it. The 0, 0 is not on your graph.
We have to do 0. We have to do a half. 1/4 minus 1, -3.
Say that again. Okay.
No, I don't want to do
Yeah,
it.
you got to do a
No, I
fraction
don't
because that's
want-
all you got in there.
Why? It's ugly.
Well, what if you
though.
have a half? No, what's half of 4?
Oh, wait a minute.
Half of 4 is 2. A quarter minus 1. A
And
quarter minus 1 is -3/4.
-3/4, so it'll be.
So I have a half and negative
6.
in there somewhere, right?
No, what?
1/2, -3/4, right?
Why is it -3/4? That's the answer. You gotta
You have to
divide it by 2.
2 over 3/4.
Oh, I got what you're saying.
Yeah.
Right, 2, and then, so it's over there, I'm sorry.
What?
But see, then is there nothing in the between there then?
Oh, wait, no, let's not, we said we had a half, our point is x is a half.
Yeah,
So x is a half, if I put a half into here, that's 2 over 1/2 times 1/2 is a quarter. A quarter minus 1 is -3/4.
yeah.
So when we divide, we multiply by the reciprocal, so 2 times -4/3, so -8/3, so 2 1/3, -2 1/3. Okay, so 1/2, -2, so it's down there somewhere.
So we were all wrong.
It's down in there somewhere.
We were
So
all
all I need,
6.
so all I need is one more point here. Do -1/2, and what are you gonna get?
Why?
This is the same thing, just.
Except for on the positive side, right?
Yeah.
Oh.
Right? Is that enough to tell you what's going on, or no?
Not really. I don't want to do it.
Well, if you put them in, you'd find it would go like this.
It's
With the exception of, there's a hole here, there's nothing there, right?
Yeah, there's a hole.
Oh, wait, no, there's no hole there.
Yeah, there is.
Wait.
There has to be a hole.
Slow down, slow down.
What do you mean
Look
slow
at, put in
down?
a 0, and what do you get here?
0.
0 over,
-1.
that's not undefined. That's 0, 0.
Yeah, but
Yeah,
you
but-
have
These,
to
these,
ask-
these asymptotes only affect, remember when we went over the definition? Hang on a second, hang on.
What?
Hang on, slow down.
No.
Don't get confused. Remember the first one? The definition of the horizontal asymptote is only affects the end points of the graph as they approach the asymptotes from the going from -infinity and infinity. It doesn't affect what's happening in the middle there. So your asymptote only affects these graphs here because these are where it's not going to touch. In the middle here is just a regular function. So that it touches here. So this is what your actual graph looks like. There's no hole there. That's just it just turns there, 0, 0.
So the ends can't touch the 1 and the -1?
Right.
But it can go through the
Right,
0.
because what this is saying is, what a horizontal asymptote says is, as you go to infinity or
Oh,
negative
I hate
infinity,
that.
it doesn't approach. It approaches, but it doesn't touch your asymptote.
Do we have to graph?
Well, yeah, because
Then
what's the
graph
whole
that
point
on
of
a
doing pre-calculus?
calculator?
What's the whole point? I told you this before.
To hate our life.
No. Why do they do this in real life? What's the point? It's not to sit down and have fun like I do doing math problems. What's the point? Why do people do it? I told you this before.
Stock market stupidity?
No. Well, you could use it this time, but that's just one small application. It's to model. Model. That's why you'll notice
Yeah.
every chapter in your book that you do, the very last section is modeling. It's a different type of modeling.
Be a model.
We did the first chapter, we did the linear, and you're gonna find that the last section of this chapter is quadratic modeling, and that'll be exponential next chapter, logarithmic. The whole point is modeling. And how do you model without a graph? So graphing and modeling is really what we're doing in this whole class. The mathematical techniques are all the sections you have up until that last section, teaching you how to model. That's the whole point of that's the whole point of the exercise. So we can do some of these. I don't want to do the homework ones though, so just pick some numbers and we'll do some. So I don't care which one.
Is there a 50?
What's that?
Yeah, there's a. Oh no, that's too easy. Too easy.
No.
Way too easy. You're not getting off that easy.
You
Well-
picked a review,
Well,
that's
I'm
why.
just gonna guide you through it. So
Okay.
start with an easy one for yourself, so that you can. Because once you
Let's
can do it on
do
your own, and then I'll walk you through
Numero
it.
dos.
Let me get a graph here.
I want to make sure we do 30.
Okay. I grabbed a graph. Okay.
We're doing 39.
Hey, I can take out my.
All right. Go ahead. What do you want to do?
Numero dos.
Number 2.
Yaks.
Well, number 2 is okay. Didn't I do that one as an example? Is that what we just did on the power start point?
Maybe.
5x over.
Okay. So, point
Let's do
taken.
number 12. Let's do number 12. Number 12 is not that bad.
Why?
All right. F of x.
Oh, actually, that isn't that
I
bad.
can't even pick a problem, let alone do homework.
F of x equals negative x plus 2 over x plus 4. Okay. Do I have any vertical asymptotes?
Yeah, we don't know how that happened.
Are you the valedictorian of your class?
I think so.
Oh, wow.
Well, I'm the dumbest
That's
in my
exciting.
class, so that
Be
explains.
proud of that. Don't. All right.
But
So
I don't know how I got to that point. That's the problem.
a lot of hard. You're supposed to a lot of studying and hard work. Where would I have a vertical asymptote in my function? Negative
What?
x plus 2 over x plus 4.
-4.
Negative 4. Good. That's really not hard. It's where do you have a 0 in your denominator?
This-
So,
Yes.
I'll make sure I
agree
start.
with that.
I'm glad you can agree with that.
Yeah, I know. 1.
Okay. All right.
No.
What about a horizontal asymptote?
1.
You tell me. What is your degrees of your numerator and denominator? Tell me how you got it.
1, 1.
Both degrees, and so when you
The
compare them, what
coefficient
does that
is
tell you?
1.
Well, hang on a minute. Start with your degrees. So you have degrees of 1 on both.
Yes.
So what does that tell you? When you have a degree of, where the degrees are equal, the
Equal.
numerator and the denominator, what does that tell you? Which rule is
You
that?
have to get the coefficient.
It
That's
was-
your
It
favorite.
was B. It means you have a horizontal asymptote
It's
at the
one.
leading coefficient.
No, it's not.
Try it again. Look at the function again.
It's -1, isn't it?
Yeah, because you have negative 1 over 1, right? Your numerator's coefficient is negative 1.
I threw a
If you
sheet
if you need to do an extra step, you can do
I got it.
you can say negative x minus 2 over x plus 4 because you can distribute the negative in if that makes it easier to see it. But yeah, x is negative 1.
That's not how I roll.
Well, I wouldn't have, we wouldn't have figured
So
it
there's your
out.
horizontal asymptote, and it's at the line y equals negative 1.
Oh.
Oh.
So that's all you have.
Let's do 2.
Well, no, let's graph it real quick. How are we going to graph this thing? This isn't that bad. Where's all you need once you see how these things work because they approach, all you need is a couple points to be able to see the. You don't have to plot 6 or 7. I know in the first question here they're going to give you they want you to plot like 4 points, but you only have to do a couple here on each side to know what's happening. So pick some numbers.
6.
You know 0 is probably going to be in your graph. So what's 0?
This is going to be F.
Huh?
1/2. Negative 1/2.
Positive.
0 is
Negative, yes, negative
negative
1/2.
1/2.
Negative 1/2.
so 0. It's right there.
It's Christmas.
Do negative 3.
Uh,
Do negative 3.
1/2.
1. Negative 1. 1.
Oh, yeah.
1.
Yeah.
1. Positive 1. Negative 3.
Whoa, all right, hang on. Slow down.
Negative 3.
You have
over-
negative, well, I said 3, right? Negative 3
Yeah.
minus 2 over x plus 4. 3
Hold
plus
up, hold
4.
up.
What?
No. If that's a positive, it's 3 plus 2.
It's 3 plus 2.
Negative 3.
It's negative, so
But then it's
you're distributing that.
positive.
But I'm confused.
It's,
Because you still have the negative on the outside.
oh.
You put
All right,
negative
all
3
right,
as a
all right.
point.
So
And
you
that's a
got 1
negative 3
over,
down there, though. Negative 3 down there.
it's, well, we said we were going to use the point 3.
What? I thought you said negative
It's
3.
negative 1.
Oh, I did say negative 3.
Yes,
You did.
so that bottom one's
Yeah, you
So
negative.
negative 3 plus 4 is
So we have a plus 1, plus 1.
plus 1.
Ah.
So this was, this up here was a negative 3. That was a plus 3 minus 2. Okay.
So it's 1.
So
I was.
we got negative 3 and 1. All right,
I
so
said
that's
that.
outstanding.
I said
So that's
1.
enough to know that you got what?
You have a weird opinion about it.
That's all. It's gonna look like that.
So it's F.
Okay.
It is F.
So what's happening over here? We know what's happening. What happens as they get bigger? Where are we at when we get to negative 10?
Oh, do we? Yeah. Let's find
10.
out.
What,
I'm excited. 8 over 6.
Negative
3 halves.
I'm sorry. What do you have?
3 halves.
You have negative
4 thirds.
Over negative 6
x
is
minus
negative
2 x plus
What did I
4.
do?
And I said use
See, when you
negative
put it
10
that way, that confuses me. I like to go by the
plus
purpose
10
one.
over negative 10 plus 4. So that's what? 8 over
6.
negative 1.5.
Negative 4 thirds, right? No. No, never mind. I don't exist.
1 and
Yeah, it does. You go divide both
4
by 2.
thirds.
it's
Negative
4
4. So negative 1 1/3. So here it's going to be negative 1 1/3. Look how close that is.
Oh boy.
So did I already plot another point over there or no?
What's 2?
Okay. So that was negative 10.
Negative
So do
5.
one at negative 5.
Negative 5.
So this would just be a 5. And this would just be a 5. So
Negative 3.
3 over
Yeah.
negative 3.
Yeah.
Negative 3. That's right.
And so now you can see that
Oh,
that's what your graph will look like.
it's F. right?
Now, when you're doing these for homework, take the time to actually put that in when you're done and see what the graph looks like. In your graph calculator, you'll know if you had the right answer before you. So you don't have to come in and say I'm lost. You know, you look and you'll know whether you got the right answer or not.
We graph
You know?
it ahead of time?
You could, but that defeats the purpose. You want to see if you know how to find them. If you put in the graph, you'll see the asymptotes, and the whole idea is you want to do it algebraically because there's going to be something you need to do algebraically. So just doing it like that is not going to help you a whole lot.
Well, I think it will. So I'll do my homework, right? What are you doing?
Just grabbing another graph.
What is going on?
I don't understand.
What magic is this? All right.
Ooh, we should do like a 30. We should do like one of those.
I've got a good one. Well, let's
Oh,
see.
you got a really good one?
Well,
Is it fun?
Let's see. I want to find one with different degrees because we know now how to do the ones with the same degree. Let's find
Oh, let's do 32. That looks pretty cool.
32
Yeah.
x
I don't know what's going on, but it looks pretty cool.
cubed minus 8 over x squared. Is this one for homework? Did you grab a homework question?
No, I didn't.
33 is the homework question.
33. Okay.
Nine-
So
33 just looks stupid.
Not looking forward to doing that one.
all right.
That's the one I'm not going to be doing.
All right. So where do I have a
Fine.
vertical asymptote?
Wait, it just says find the zeros of the rational function. Use a graphing utility to verify your answer.
Yeah, what does that mean? That's
Fine.
why I picked
Didn't we already
it.
do this?
Finding the zeros. They want to know
Why?
where. Why do they want you to find the zeros?
No, what? How? I meant
How do you find
not
the zeros?
why. How?
4i and negative 4i.
Very good.
Yes.
Oh, and that's.
So those are
that's the
imaginary.
last section,
So that
yeah.
so you won't have any. All right, so that would be the zeros.
It's just what it says. It says find the zeros of the rational function and use a
Okay.
I
graphing utility
forget
to
how to
verify
do
your
the
answer.
cubic.
Okay. But so there's not going to be any. So that tells you what? Then why do you want to find the zeros? What does that tell you about your vertical asymptote? You're right. They're imaginary. There's no real asymptotes. There's no vertical asymptotes there. There's no point. There's nothing you can put in here in your domain that will give you a zero here,
Just make my life easier.
right? Nothing can give you a zero.
It's impossible.
All right. So what about a horizontal asymptote?
3. No, can't be possible because the numerator is greater than the denominator, so it's impossible.
There is no graph for this function.
It does not. Wait, I'm wrong?
I didn't say that.
What do you mean?
I didn't say you were wrong. I'm just going back to our.
Oh,
Yeah.
I'm right.
Am I right or am I wrong?
Yeah,
Just
I'm
tell me
confused.
straight up.
This you have a larger one in the numerator than the denominator, so you have no horizontal asymptote. That's how you know that.
So this
You'll see.
graph doesn't exist.
No, it exists. Just no asymptotes are on it.
No, it doesn't exist.
What do you mean it doesn't exist?
There's no asymptotes.
Well,
But that means there can still be a graph without an asymptote.
the zero,
It doesn't
the point zero and a half is on it, right?
It shouldn't exist.
Well, what do you do if? Well, let's
Oh, it does exist.
let's figure out some other things. Okay.
0,
so-
negative 2.
What's that?
I
Well,
plotted
what's
the
zero? Okay, so that would be 0, -2. Okay.
point. You think I pulled these numbers out of a hat?
Sometimes I do, yes.
6 and 24. Go.
No! 6, I just did math wrong in my head. That.
Oh, I know. That's how I just picked random numbers instead of allowed.
I didn't mean to read
Which
this.
reminds me of my, I was in a meeting one time
Oh, gosh.
at work, and we were talking about projections and where we've been for our derivative deficits, our derivatives and finances or partials of financial functions. And so I said, well, 16 years ago we had a -3 balance on our derivatives over a 6-year period. And as I'm leaving the room, the president of the company comes over to me and says, how the heck can you remember 16 years ago that we had this and this and this? And I said, I was right about that. He goes, see, that's what I thought. Okay. So, all right. So we know 0, 0 is, or 0, -2. What else? It gets harder after that.
Yeah, it really does.
8.
So this is really no different than what we did in the
2
last.
is 0. 2 is 0.
Huh?
2 is 0.
2,
No, it's not.
0.
Wait, yes, it is. 2, 0.
2 would give you that. 2 would be. Oh, I got you.
I'm right! I told you. I know what I'm doing,
All right.
Mr. Sager. Don't
Lost.
use
Is that-
What are we doing again?
We're just plotting some points to graph it, because that's what you want to do, but is there anything else we can do to,
Why?
because this one's not going to just, well, what would you do next?
7/5 and a negative 7/5. 3 is 7/5. 1 is negative 7/5.
Okay.
Do one.
So you're just gonna keep picking numbers until you get like a
It
million
does a thing.
scatter plots, and then
Yeah.
you'll then just sort of follow where it happens.
Yeah.
You could do that. That might take a while because you have to plot a lot of them to see them.
Wait, there's an easier way?
Well, what did we do in the whole last section? What did we learn? I mean, all this stuff connects together.
Wait a minute, there's only there's only 3 zeros.
What does it
and
tell you that you have?
There's only
What
one
does this
possible.
tell you when you have this? That
There's
tells you
only-
that you have a factor of what? X minus 2i, x plus 2i, right? You know those are factors.
And there's only one more zero you can have, and it's
Okay.
what I just found. Oh.
It can only have.
So it's
Right.
x minus
That's the only place it's going to touch that axis, but that still doesn't tell you what happens to the rest of the graph. You're correct on that. That's only going to be the only
But the
intercept.
other zero, the other
All right.
zero.
What about synthetic division?
Why?
Well,
We
'cause
can't.
Can't you divide?
Zero, I
Can't you
know.
divide x squared
Oh,
plus
yeah.
4? Can you divide these?
Why?
I'm defined.
Let's do it for fun.
Well, we know those. All right. I see what you're saying. You only have 3 factors. Let me put it this way.
What did I do?
Answered how many factors? Linear factors you have, which was x minus 2i, x plus 2i, and now you know that it's x minus 2, right?
Yeah, but you can't
I
make
guess you use
that
that-
that.
Well,
But how do you make that into that? That's what I don't
how do I
understand.
make this into that?
Yeah. You can't.
Well, you could multiply it all if you wanted to, and
Yeah,
then
but it's not
take
gonna
common.
do that.
What's that?
It's not good. I don't know.
This-
I don't exist.
This is a numerator of one function, and you're dividing it by another function. Okay. So what am I going to have here if I take my leading coefficients of those? You could take your leading
One.
coefficients of 8, and you could do synthetic division with 1, 2, 4, 8. And then you could do that. Take it over the bottom one, 1, 2, 4. That's a lot of math to go around. Plot it in your graphing calculator and see what it comes up with.
See, this is dumb.
Graphing calculators?
No.
Well, what is it we're
Graphic
referring to in
calculator
particular?
is the best thing that happened to me in math life. See, there's been 3 different lives.
I just hate this.
Math life, I lose a life every time I come here.
Oh, just.
Cat, probably only have like 3 left. What am I putting in again?
Yeah, I don't know.
X cubed minus 8 over x squared.
Yeah,
plus
it's this ugly, stupid thing.
Oh, why is it ugly?
I don't know. It's weird.
Ew.
Why?
Looks
Oh.
like a
You get a
mountain.
different view in Windows.
Looks like
We do.
mountain climb.
I don't know if you. X
Hill
cubed
climb,
minus
that's what
8
it is, hill
over
climb.
x squared.
Oh.
Over graph is right. Is your graph?
Yeah. Mine's at 6.67. Hers is at 7.3.
Wait, no, you have something totally different. You have
What?
x cubed.
What did I
You got a
do
fraction.
wrong?
You got a fraction in there. or
It's
something.
supposed to be a fraction.
But you're using the quotation mark or the parentheses to make your numerator and then divide it by the
I
parentheses of the
don't
denominator?
want to do math.
That will
I
help.
just do control and then hit the divide button and it gives me a little fraction
So
thingy.
you know more about using this than I do because I can't. I would have had typed the parentheses. You have the other things. So
I know nothing about this calculator. This is
I feel
ridiculous.
smart now.
Is that? Oh, I got it.
You know, there are tutorials on my Wikispace for how to use that calculator.
I couldn't understand.
I
the
got it.
tutorial.
I got this calculator.
here's a
There's
book
also
too.
a
I read,
TI Inspire for Dummies book that I said.
yeah, I read some of that book and that was helpful. I just haven't had a chance to